Hello, and welcome to this demonstration of IBM's Data Power Operations Dashboard, or DPOD for short. In this video, we will show you how to deal with various latency issues, which may arise when working with API Connect services. We will demonstrate two scenarios, one with slow latencies, and another with variable latencies. Moreover, in this video we will demonstrate various DPOD features, such as the latency dashboards, comparing API versions, using global transactions, payload capture and variable capture, and configuring alerts. So for the first scenario, let's say you're the gateway administrator. A user calls and tells you that one of the APIs is working too slowly, and asks that you investigate the issue. Let's see how DPOD can help us investigate this problem. The first thing we need to do is verify that what the user said is correct. To do this, we will go into the API latency page, under Analytics, and filter by the appropriate API name and app name. Filtering by consumer application name will make sure that we only see problems in calls invoked by a specific consumer application. We can see that indeed, the latency of this API is quite high, between 8 to 10 seconds, and this has been the case for quite some time. To investigate further, let's go to the Transactions page. Note that we still see results filtered for the API and app name we have selected in the previous page. This is a general feature of DPOD. When you switch between pages, you will only see information relevant to the filters you've selected, when they are applicable. This makes the experience of using the DPOD console easy and seamless. Now let's zoom into one of the transactions. If we scroll down in the transaction page, we see the execution path of this API. If we look closely, we can see that one of the policies takes up most of the execution time. Invoke get balance takes over 6 seconds to complete. Let's go into this policy. Here, we can see that there's a side call, which takes 6 seconds. This is an internal side call to another API within our API Connect network. We know this by the way this URL is formed, first the provider organization name, and then the catalog name. In other words, this API calls another, nested API, which is also managed by API Connect. This means that we can investigate more deeply, since the nested API will also be monitored by DPOD. To do so, let's copy the global transaction ID and go back to the transactions screen. Global transaction IDs are automatically generated by gateway devices and are retained when internal API calls are made to nested transactions. Therefore, we can use the global transaction ID to easily find the internal call made by this transaction. So let's reset the filters and use the global transaction ID to find the transaction of the nested API call. Indeed, we see two transactions. One by balance convert, which is the first API executed, and another by accounts balance, which is the called API. Let's go into the nested API and see how it executed. In the API execution path of the nested transaction, we see that the getBalance invoke policy takes up 5 out of the 5.5 seconds of the total latency. If we click the getBalance policy and go into the details, we see that a call is made to an external service, called AccountService 102. Note that this URL includes what appears to be a version number, 102. This will be significant later on. At this point, we already know that the source of the slow latency is this external call. We could now call the person in charge of this service and tell them about the problem. However, before we do, we should check whether this service is always so slow. To do this, let's go to the API Policies dashboard, which is also under Analytics. Now let's filter by API name. Since we already know the problematic policy, we can also filter by policy name. Here we see something important. In version 102, executing this policy always took around 5 seconds. We can see this by the average, maximum and minimum latency columns. However, the same policy in version 101 took only 164 milliseconds to complete, which is 10 times slower. Such a difference in performance must be significant. Let's try and see what happened. We should try to find out what is the difference between version 102 and 101. If we hover over the policy version, we can select to filter by the older version, 101. Now let's go to the transactions page, go into one of the transactions, and go into the Get Balance policy. As we can see, the policy calls a similar URL to what we've seen before. However, this time the URL has a different suffix, the version number 102 does not appear. This means that the older version of the nested API calls a different URL than the newer version. We now finally understand what is the source of the problem. In the new version of the API, a nested API was called, which also had a newer version. The new version of the nested API calls a different URL than the older one, which is significantly slower. To resolve this, we need to call the owner of the external URL we are invoking, and tell them there are big latency differences between the two versions they've deployed. Now that we've pinpointed the issue using the DPOD console, it is up to the API owners to resolve the issue. But before we move on, we can do one last thing. We can decide that we want to make sure that if this situation happens again, we will know about it. DPOD allows us to create an alert that will notify us when any API is taking too long to complete. To do this, we can go into the API URL calls dashboard, under Analytics, and filter by the URL name of our API, which we've previously saved. Now, if we hover with the mouse over the average latency column, a pop-up menu gives us an option to create a new alert. This alert will notify us if the average latency goes over a certain threshold, given various conditions which we can configure. As this is only for the sake of the demonstration, we will not save the alert, and exit the page. To summarize, in this scenario we've seen how we can use DPOD to identify the source of latency problems. By leveraging DPOD's dashboards, we can easily identify latency differences between API versions, and use transaction global IDs to investigate internal calls. We can also create alerts to make sure latency problems do not repeat themselves. Now let's look at another scenario. In this case, a user calls and says that the latency of a service changes from call to call. Sometimes it's around 8 seconds, and at other times around 10 seconds. To investigate issues like this one, it is often necessary to turn on payload capture, so we can see whether variable latency durations are the result of different payload contents. DPOD makes turning on payload capture very easy. In the Transactions screen, select the Payload Capture tab, and create a new subscription for the device and domain. Since we've already turned on payload capture earlier, for the sake of this demonstration, we will cancel this action. Once we've turned on payload capture, we need to ask the consumer to invoke the API again, so that the capture will collect some data. Let's say we already did that. To examine the payloads, let's go to the Transactions page, and filter by API and API version. We can see that indeed, as the user said, some transactions finish after 10 seconds and some only after 8 seconds. To understand why this occurs, let's open a sample transaction from each latency in a separate window, and put them one next to the other. This way we may compare their execution paths and latency durations. We can see no visible difference in most of the policies executed by this API. The policies executed are the same, and latencies are very similar. However, when we scroll to the right, we can see that a policy called getExchangeRate takes 2 seconds more in the slower transaction. So this must be the source of the higher latencies. But why does it happen? If we look at the external calls made by these transactions, we see that they call different services, one for a currency of US dollars and another for euros. But the question remains, why do these two invocations call different URLs? Let's look at the message payload of one of the transactions. We see that the API consumer has sent a currency of euros within one of the fields of the message payload. Now let's look at the payload of the other transaction. Our suspicion is verified. Here the consumer sent a payload asking for a currency of US dollars. We have now pinpointed the source of the problem. When consumers call the problematic API, they do so with different payloads. This payload then determines which external service is called. According to the currency requested by the consumer in the message payload, sometimes a US dollars service is called, and at other times a euros service. These two external services have very different latencies, which is why the total API latency is so different. To resolve this issue, we will probably need to contact the owners of the slower service and let them know that they have very high latencies. As you can see, in both scenarios DPOD has allowed us to resolve complex latency issues simply and effortlessly. Everything was done from a centralized console, without having to log into separate gateway devices, call the owners of each API, or dig through the logs. This concludes our demonstration of using DPOD to resolve common issues in invoking API Connect services. We hope you found this demonstration useful. Please look at our other videos for more scenarios, instructions and features.